Welcome back to the course on electronic packaging and manufacturing. So, in the last class we had started our discussions on second level packaging and we discussed about printed circuit boards or printed wiring boards. Okay. So, today what we will do is we will continue from there. We had just discussed about multi-layer motherboards. We will just do a recap of that and then go to circuit board materials, and this is going to take us some time. So, that is the concept that we are going to cover today. Okay. So, circuit board materials, as you can see over here, is what we are going to cover today. So, before that, just a recap from last time, we talked about multi-layer boards and where we said that there are internal wiring traces. So, if you see over here, so this is a picture, what you see here is this is like a cross section of the motherboard. If you take this green thing that you see a few millimeters and you actually take a cross section and look along the side under a microscope, this is what you should be able to see. You see here, these are internal layers. You can see this copper, these are like wiring traces. Okay. Now, this interconnection point probably needs to talk with this connection point or the wiring trace. So, how is it being done? It is going to be done with this vias, which are small holes, but then connected by filled in by this copper or conducting material. Okay. So, these are also sometimes called copper bumps, all right, and then you see traces at the top layer and the bottom layer. So, this is a circuit board, 4-layer circuit board with, as you can see, 4 layers of wiring traces, the top and bottom, and then 2 internal layers. Okay. Now, one thing that I want to show you over here is an example of laptop motherboards. Okay. Now, look at these motherboards. These are both from 13-inch laptop computers. On the left you have Dell Inspiron and on the right you have an Apple MacBook Air. Okay. You can see all these so many materials densely packed. These are typically double-sided motherboards, in the sense components on both sides. But one thing that you readily notice is the fact that the motherboard for the Apple computer is so much smaller compared to the Dell computer. And the reason is the Apple motherboard has more layers compared to the motherboard on the left in the Dell product. Okay. I do not know exactly what this is, but it was few years back it was common that most laptops had 6-layer motherboards, whereas the Apple laptops used to have 8 layers. Okay. So, what does this do? This enables or basically a motherboard or a circuit board, in this case of course, I can use the word motherboard, with more number of layers, wiring traces or layers of wiring traces will enable us to put more number of components and connect them, interconnect through the interconnection points or interconnect them properly over a much smaller real estate, right. So, that is what has happened, whereas if it is a motherboard with less number of wiring layers, then I need that much more of surface area or real estate or footprint area for all these connections to occur or to be included. So, basically what happens is, in one case I need more surface area, in the other case, well, I can go vertically up. So, it is like, you know, if it is a multi-storied building, I can have 10 families stay one on top of the other, but if it is a single story house, then I will need 10 such small houses, single story houses. So, that will take up a lot of floors, a lot of space on the ground, a lot of land. Okay. Same thing over here, right. So, you see the two. Now, the point is, however, nothing comes for free, and as you keep increasing the number of layers in a motherboard, its cost also goes up. Okay. So, it is quite evident. So, therefore, if you look at the other side, there was a time when we were talking about netbooks, even today also we have these smaller computers. Okay. So, here which are not functionally, which are good enough for your day to day use, but otherwise in terms of performance, speed and all, which are they are not top of the line. So, these computers sometimes have motherboards that are 4 layer, okay, lesser number of layers, because you do not have so much of functionality, so many interconnection points and so on. Okay. The processors are not that powerful, not that many interconnects. So, in such cases you can go with lesser number of layers in the circuit board. Okay. So, if you look at tablets, smartphones these days, probably they will have primarily not too many layers inside them, definitely not 6 or 8. Okay. So, here we see this, and that gives you a feel of how having more number of layers or wiring layers inside the motherboard helps us to go smaller in size and sometimes even thinner in size. Okay. This Dell laptop, for example, this motherboard is placed towards the back side. If you look at your keyboard, it is more towards the top side. Or okay. So, therefore, when you look from the side, it appears so thin, because for most of the things it is just the keyboard and nothing else, keyboard and the bottom chassis and maybe some connecting wires or cables. Whereas, if you look at the Dell system, you will have the motherboard extend for a large extent or occupy a large part of this footprint area, and therefore, this motherboard having components on both sides that need clearances, etc. The laptop, if you look from the side, will also be thicker, the thickness will be higher. Okay. So, just to give you a small example, taking a cue from our discussion on multi-layer motherboards. Okay. So, let us now go with circuit board materials. So, what is the selection criterion for circuit board materials? Okay. Before we go into what materials to use, if I have to choose a material, what are the considerations that I should keep in mind? And number 1, cost. Okay. Cost is extremely important in this industry. It is a very cost sensitive industry, unless you are talking about military, defense applications and all, aerospace, which are different, but consumer electronics is an extremely cost sensitive market. Okay. So, therefore, any means of reducing cost will be welcome with open hands. Okay. All right. Next, electrical characteristics. What is the surface resistivity? Okay. You do not want leakage of current from the surface, right. What is the dielectric constant? A low dielectric constant is desired because that helps in signal processing and signal integrity. Okay. Then dissipation factor, what is the measure of leakage power or leakage current, right. So, loss or leakage of power, that is the dissipation factor, very important for the circuit board material. Okay. So, that cost, those are electrical characteristics, very important, but so are mechanical properties. So, from mechanical properties, what do we see? What are the desirable characteristics or the properties of importance? Structural point of view, modulus of elasticity and flexural strength. Okay, very important. Then the dimensional stability. Okay. So, these motherboards I should be able to design in various shapes, I should be able to have cutouts, etc. And the other thing that we need to keep in mind is CTE, the coefficient of thermal expansion. Here I take you back again to our discussion in first level packaging, where in flip chip bonding we talked about the underfill epoxy. Remember what was the primary function of that underfill epoxy? It is because the solder balls that are connecting the silicon to the substrate, which can by the way be a printed wiring board material and it can be an organic substrate, is undergoing a lot of thermally induced stresses because of the mismatch in coefficient of thermal expansion between silicon and the substrate. Okay. So, if I now attach a substrate on the motherboard, the same consideration should be taken into account, okay? Because as you power on your product, due to flow of current and all, there will be localized heating which is going to increase the temperature and these materials are going to expand. So, that coefficient of thermal expansion, the material has to be chosen so that the CTE is something that we can sustain, we can handle. Okay. Glass transition temperature, that is a mechanical property, TG as we call it. So, that temperature is also important because when you are fabricating the motherboard, during the fabrication process as well as during operation, we should not be exceeding the glass transition temperature of that material. Otherwise, there will be big change in physical properties or even chemical properties as well. Okay. And finally, extremely important under mechanical properties is resistance to humidity. Moisture is a big enemy of electronic products, okay. And there will be moisture ingress, you cannot help it. For organic materials there will be, for the regular motherboards that we see, for plastic molded packages there will be, for interconnect silicon, any of these epoxy materials, it is bound to happen. Moisture ingress is inevitable. Okay. If you want hermetically sealed packages etc., you have to go for ceramics, specialized ceramics, very expensive. Okay. But then even among the materials which are cost effective, resistance to humidity is of paramount importance, and we must keep that in mind when we select the material. Okay. What else? Physical properties, corrosion and moisture resistance, we talked about that, okay. Especially moisture resistance, able to drill through, because many a times as we saw in that picture, we are required to have these holes in the motherboard, plated through holes in the motherboard, and that is important. And finally, thermal conductivity, it is a thermophysical property, extremely important, because from the point of view of heat dissipation. Okay. The component is going to generate heat, okay, and that heat has to be conducted through the motherboard. A lot of that heat, if I can conduct it through the motherboard, then it will help me in maintaining the temperature below the acceptable limits. Okay. Even for flip chip packages, where the silicon is inverted or flipped over, so that the back side of the silicon is available for placement or positioning of a thermal solution, even then if some of the heat can be conducted through the motherboard and dissipated, it helps us. So, to this end, thermal conductivity becomes very important, and the thermal conductivity is going to be number one, anisotropic, because what is there? This is a laminate structure, you have copper traces, wiring traces, and then you have this organic laminate made of glass cloth in a polymer binding. Okay. So, these are in the form of laminates, therefore, the in plane thermal conductivity and the out of plane, the normal plane thermal conductivity are going to be different. Normal plane, in plane, different thermal conductivities, and we must keep that in mind. Also, In areas where there is very dense circuitry, the thermal conductivity will be more because you have more copper, more traces over there. Okay. So, knowledge of this thermal conductivity is very important, especially when we do thermal modeling, and particularly for those packages which are not flip chip package, where you do not have a dedicated thermal solution on the back side of the silicon and you depend primarily on the conduction through the motherboard. All right. What next? So, now let us look at some of these materials that we are talking about. Okay. So, glass fibers, you see this. So, glass fibers are there that make up the one of the major materials of the printed circuit board, the laminate part. So, the glass compositions, there have been several glass compositions have been looked at for making the material that is used in circuit board, but probably right now there are only a few of them which are most popular. And the most popular one is called, I mean they are classified in a nomenclature is like A glass, B glass, C glass, D glass, like that. So, the one that is most commonly used in printed wiring boards is something called the E glass. We are not going to get into the details of all these, but the glass material that is used is one formulation which is known as E glass. Okay. These are all electrical grades. So, the 4 main glasses that are used today are the electrical grade or E glass, something called a C glass, which is an E glass which is chemically resistant. Okay. And then there is something called S glass, which is high strength silica glass, and then finally something called D glass. Okay. So, E, C, S and D, these are the 4 major types of glass materials that are used as one of the components that are used or that goes into making of a motherboard. Remember, we use glass cloth, glass fibers. So, this is the glass that goes into making that cloth or the fiber. Okay. S and D glasses are also typically used to lower thermal expansion, okay, for lower dielectric constant or provide high temperature stability. Okay. But E glass today is the most common, and it is also, and because of volume manufacturing, it is also the most inexpensive among all of these. Okay. But for specialized applications, C, D and D are also C, S and D are also used. Okay. And then remember, we said we need glass cloth. So, of course, this is a glass, but then this glass has to go into a fabric material. Okay. So, these glass fibers are used to make these fabrics, which are planar structures. You can see these crisscross structures on the left hand side. These yarns are interlaced at right angles to each other to form a fiber arrangement. Okay. All right. And then, so this is the glass cloth or glass fiber that we are talking about. And then what did we say? The laminate consists of this glass fiber in a polymer setting matrix. Okay. It is a binder. So, that you see on the right hand side. This is a typical fabric we have impregnated in epoxy resin. Okay. That is the polymer material. So, that gives me my the basic motherboard structure or the circuit board structure. That green thing that you see is actually because of these. All right, we will come to that more. We will come to that. So, what are the common circuit board materials? So, we talked about the glass, and then it goes into this polymer, and finally, what you get, these are named in terms of, or these are, the nomenclature is something called FR followed by a number. Okay. So, FR stands for fire resistant or fire retardant. think one of the two. Okay. So, FR, so under the construction of or depending on the materials that have been used to form the laminate, the nomenclature happens in this form. The first one is FR1, which is also sometimes called XXXP. This unwoven paper fabric with phenolic resin. Okay. So, low temperature, low cost material used mainly in single layer unplated boards. Okay. FR2, but here what happens is pretty much FR1, but the phenolic matrix has some additives to make it fire resistant, or rather more fire resistant, and that is why FR2. FR1 is also fire resistant, FR2 is even more resistant to fire. So, here my friends, I want to just mention the importance of this term FR or fire resistant. It is very important from the reliability point of view, because short circuits can happen, overheating can happen, but then this circuit board, because of its nature, resistance to fire, sometimes prevents the whole system catching fire and leading to some catastrophic consequences. So, FR, the circuit board material, prevents, many at times saves us from such consequences. Okay. Let us go to FR4, which is the most commonly used material today. FR4 is woven glass fiber fabric in epoxy resin, moderate temperature, moderate cost, high reliability material. Used widely today, as I said, it is the most commonly used for both double and multi-layer plated boards. And what are its properties? Some of it I have written here: low glass transition temperature, fire resistant, CT closely matched to copper. This is important because the laminate is going to have copper traces in between. So, if the CTs are very different, then it is going to have a problem. It may lead to buckling or bending because of differential expansions. So, CT is closely matched to copper, and the elastic modulus is also quite high, 3 to 4 megapascals. All right. And finally, there are also two of them, FR5. This is also high temperature, high cost tetra functional epoxy version of FR4. Okay. This can be applicable, this can be applied to temperatures, subject to temperatures below 185 degrees centigrade. So, FR5 definitely is more costly, used for specialized applications. FR4, as I said, is most common. And finally, if you want to go really high temperature applications, polyamide glass or quartz. So, these are very specialized materials, but very high cost as well. Okay. So, let us quickly recap what we just saw. Common PCB materials, fire resistant, as we were talking about. FR1. So, this FR1, FR2, FR4, FR5 and finally quartz. These are all classified based on the materials that are used. And when I say materials, what are the materials that goes into it? Number 1 is the glass fabric or the glass fibers, and number 2 is the polymer matrix that binds them together. Okay. So, based on this, these materials, the fire retardant boards or FR boards are classified into FR1, FR2, FR4, FR5 and quartz, and there are some other variants as well. But out of these, what I want to say is FR4 is the most common, okay. That is most widely used. All these green circuit boards that you see when you open your laptop computers, when you open your cell phones, when you open your, I mean even if you open your let us say what is called your USB drives, there also you will see a teeny mini circuit board. Okay. So, all these are very important. Okay. FR4 is woven glass fabric in epoxy resin. So, moderate temperature 135 degrees centigrade, but if you look at most of the consumer electronic products, the temperatures do not go beyond this, actually stays well below these temperatures. Okay. For example, if I talk about a computer, the silicon temperature, which is the highest temperature, should be kept, typically is kept below 100 degrees C. So, the motherboard or any of the daughter cards or the circuit board temperature will be lower than that. Okay. But however, we want to go a little higher, because many a times under under cases where it is abused or where it leads to failure, the temperatures can overshoot. Okay. It can lead to overheating. If there is a short circuit or some of these interconnects get shorted, get broken, bent or shorted or some whatever happens. So, it can lead to some thermal runaway conditions where the temperature can go up. Okay. So, that is why FR4 135 degrees C for most of the common consumer electronic products that we use, that is considered to be safe. Okay. Is moderate cost very important, because as I kept saying, this is an extremely cost sensitive industry. So, the cost has to be kept in mind. It is high reliability material. So, it does not go bad unless it is abused all, it lasts. Okay. So, that is why it is most widely used. Okay. And again the other point I wanted to make again, because from my thermal background, is about the CTE match. You have these laminates and then you have these copper traces going through them, the wiring traces. So, their coefficient of thermal expansions must be maintained close to each other, because otherwise what will happen is when they heat up and if there is a differential rate of expansion, they will just bend and the motherboard will bend, and that can lead to a lot of things. Think about it, a motherboard is bending and then you have, let us say, ball grid array package on top of it. What will happen? It is going to give a lot of stress to the solder balls in the ball grid array package, and some of those solder balls can crack and connections may be broken, and it can lead to complete failure of your product. Okay. So, circuit once again printed circuit board extremely important, and today what we talked about are the circuit board materials. Okay. We talked about basics of what goes into a circuit board, we talked about a laminate and we talked about wiring traces, and then what we were looking at are the materials that are used to make these laminates. So, in the next class what we will do is, now that we have the laminates and we know what the laminates are made of, in the next class we will look at how we first of all manufacture this copper, and then once I have this laminate and I have the copper, what do I do to bring them together, and what are the fabrication techniques that we use to finally give shape to the final motherboard. Okay. So, with that I come to the end of this lecture. Thank you very much, and when we come back we will continue from here. Thank you.